Okay, so I'm the co-founder and CEO of a company called Bauplan, and we help companies write and run pipelines and jobs in Python directly over S3. You can think of what we're building as a code-first Pythonic lakehouse. The runtime is serverless, the programming model is heavily declarative, and is built for reproducibility end-to-end. So essentially, you have code, environments, and data that is automatically versioned in a way that makes developing data applications particularly software development friendly, in a particularly software developer friendly way. I built, before I spent a few years in data, I built a company in machine learning and natural language processing, brought it to acquisition, led AI at Coveo, and from scale up to IPO. My team and I spent like a lot of time essentially building search and recommendations. And in 2017, that was just few people. So we spent a lot of time basically doing AI and data embedded in end-to-end applications that have a touch point with a user in the end. A lot of that went into the thinking around Bauplan and what we tried to solve. Like we essentially think that the end-to-end management life cycle of a data applications should be much, much easier than it is. And so that is like, this is going like boop, 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 boop. Is this driving you insane as well? Is it okay if I just yell? Because I can totally yell, I'm Italian, it's fine. Okay, like, give me, okay. We're gonna do it like rappers. Okay. Does it work now? Okay, okay, fantastic. All right, so I was saying, where was I? Yes, so data applications. So essentially, what I'm trying to say is that we didn't spend a lot of time doing like data science as in, you know, I have a bunch of data, I analyze that, and you know, like your output is essentially a notebook or like an ad hoc analysis. We always put a lot of thought in end-to-end applications. So that's what we're gonna talk about, is how we build the platforms and the lesson learned. If you wanna use our platform, you're welcome. If you don't, build your own. This is like, just like more lessons learned, and I hope this helps the community. We heavily rely on open source in the community in building this. Also, I think that the abstract of this talk has been generated by an LLM, so there's a lot of promises that I'm not gonna keep, just for you to know. Okay. Anyway, so let's start with this. Like, so the big thing that happened in the past years, of course, in data is AI. Now, there are a couple of things that we think are more important than others in the way in which AI kind of like changed the way people develop. Well, one of them, of course, is that with pre-trained models, the way in which people develop AI is very different, is through APIs. And that means that essentially you have, you know, AI capabilities that now are in the realm of software developers that were just like unthinkable a few years ago. And also that your programming model now is kind of like API based. So a lot of your your AI application, for instance, is going to be essentially data plus code. Now, when it comes to code, of course, like if we do AI and data, 90% of that means that you're doing Python. That's because like Python is the lingua franca for data science and machine learning. It has been like that for a long time. It appears that now is even more popular than JavaScript, which is insane. But generally speaking, like the growth of Python seems to be pushed a lot by AI. I don't think there's like really a strong argument for things like Python is going to take over SQL. I think like most code bases for AI applications will look like a mix and match in the future. But the bottom line is Python is getting like increasingly important in a world where AI is done with code and data. Now, the second thing that is very important is that there's a pretty strong shift, like push to shift from analyzing data to using data to build stuff. Okay, and as I said, like when we started our company, I was doing AI for search and ML and recommendations. There weren't like a lot of people doing what we were doing. Like most data scientists, like in 2017, were actually doing analysis, offline predictions, like notebooks essentially. But right now, I think like it's more the norm that you have actual applications that have a touch point with a user and a customer. And because of the nature of what LLMs are so good at solving, you have things like RAG, or you have co-pilots, you have agents, you have conversational UIs, you have recommender systems. So these things are more like applications than just like data analysis. So if you take like a simple case like a RAG, applications where you know how this thing works is essentially there's a user that is prompting in an LLM. Now we have a bunch of documents that we embedded and we put in a vector database. So now when the prompt comes out, instead of going like directly to the LLM, we're going to basically retrieve some documents based on that prompt. We're going to put it into context so that when the LLM answers, the LLM has more context about the answer, and so that ideally will make like your answers more relevant and the LLM less prone to hallucinate. This is a simple applications. There's plenty of applications like this out there now. And it kind of illustrates the point that I'm making. Like embedding AI in this application is essentially an API call with an LLM. But most importantly, now this is a user-facing application. And like every user-facing applications has an end-to-end life cycle that needs to be managed. It has a backend, it has a front end, and it has a DevOps cycle. So when you deal with an application like this in production, you're essentially will have to bring like a bunch of people that come from different tribes in your company or in your organizations. So you're going to have like data scientists and data engineers who are going to be working on the ML ops, data ops, LLM ops kind of part of it. But you're also going to have like just like software engineering, software engineers that manage like the applications, and DevOps people who are there to make sure that deployment is robust, that we have like CI/CD in place, that we spin up infrastructure in the cloud in the right way. Now, these three groups of people have very different tools and very different also goals in life, really. Like they care about different things in this kind of like end-to-end life cycle of the applications. But one thing that they have in common is code. And that's pretty much the only thing that they have in common. And I think that a lot of what we want to say with what we're building is that data platforms, as of they are today, often provide ways of doing things that are openly an anti-pattern when it comes to software engineering. Notebooks, right? Which are not great from a software engineering standpoint because they're brittle, they're hard to test and maintain in production. Lots of YAML, which is great, but I cannot really program with it. Or just GUI-based workflows, right? Like when you open up like a UI and somebody clicks on something, or you do something like, with a drop-down menu and so on. Like all those things like are really hard to put like in an application that is just a software application. So what I'm trying to say is that like AI is kind of like pushing data towards software engineering, and as a community, it would make a lot of sense if we start thinking more and more about building tools for, especially around data platforms that are more software engineering friendly than what we have today. Because if I have to go and look at what people do, for instance, with Python, it tends to be historically pretty messy, okay? So there's a lot of local stuff that happens, like you basically load your CSV file into a pandas data frame, and then you do your thing, and then you save it like another CSV file. Anyone? Yeah. Dependencies are super messy, works on my computer, but it doesn't work like on other people's computers. A lot of stuff that happens in the cloud happens in tools like Airflow, and there's nothing wrong per se in the orchestrator, but like a lot of your business logic, it gets like crammed into that. And so now you have, the actual transformation logic, the data, and the code are kind of like loosely coupled now. So it's hard to maintain, it's hard to debug. There's really not a very clear reference cloud implementation for running, like Python for data in the cloud. So even though like Python has been like the lingua franca for data scientists and machine learning engineers for such a long time, it is so important and it's growing, no one really built a truly Pythonic data platform as of today. As a matter of fact, if I go and look in what data platforms are historically, they kind of look something like this. So I'm going to spend a little bit of time on this slide, so I'm going to go through this like in a kind of pedantic way. Whatever you do, whatever is your use case, whatever your company does, your data platform will minimally support these three use cases. Interactive queries, there's a person who wants to see something in a table. and we'll just like ask a question to the data. So that's usually a SQL query, and there's a person on the other side with a quick feedback loop, and they want to see the results. Then you have building pipelines and building models. So we're doing something more than just a query. We're building something more complicated. We're building a pipeline, but we're developing. So there's still a human being that is iterating on the code. And then that pipeline goes into production. And it goes like in a different phase where we're going to think about orchestration and optimization of resources and so on. As of today, like these things are like very, very different. They have completely different infrastructure, for instance, like to begin with, right? So you query your data with stuff like AWS Athena or your warehouse, but you develop your pipeline using things like single node Spark, for instance. And then you move to your orchestration and production phase, and now you're going to have clusters. You're going to have Kubernetes, you're going to have Spark clusters, Ray clusters, things like that. It's a completely different developer interface. So you write your SQL queries in a SQL editor. You write your pipeline, you develop your pipeline in a notebook in an interactive Spark session, probably. You put things in production in VS Code. And now you think in terms of orchestration tasks and so on. So also the abstractions are different. Tables and views for when you explore, data frame, DAGs, models when you develop, but tasks, retries, configurations when you run things in production. And in my experience, going from column 2 to column 3, it's like a lot. How many people in this room worked at least for once for a company that takes a long time to take a prototype that is built on a notebook or on a local machine or in a dev environment to bring it to production, and that process takes weeks? All right. Congratulations for those who never had this experience. I envy you so much. That's because there's a lot of refactoring involved. You have like a notebook and now you have to turn it into actual code. The teams are different. Literally the teams are different, right? There's this kind of like handoff that takes weeks. So that's not great if you want to build like applications that are more like, kind of like software-like. We should have like a better way to iterate on applications and be faster and cleaner in doing the whole life cycle. The second thing that is not great if in the perspective of building data, in doing data in a more software engineering friendly way is reproducing things is pretty hard, right? I'm pretty sure that everyone in this room had this experience, you know, like pipeline breaks, we don't exactly know what happened, but we have to fix it and we have to investigate. So as, you know, a software engineer, you're gonna go, all right, so I'm gonna reproduce that. What's the problem? And just like see what it is. But the problem is that data add a dynamic component to this reproducibility problem that is not necessarily there when you just do software. So to reproduce a pipeline that fails, you got to go back and say just like, oh, what was the version of the code? What was the environment it ran in? What was the data? And in my experience, these three things are in completely different places. And it takes a village to pull them out and put them in one place so you can debug. To be fair, in my experience, the data component is never really there. So like new data came in, it just washed out the old data. And my experience with debugging a pipeline is just like, I'm going to rerun this. And if it runs, we're just going to pretend it never happened. All right, okay, so I'm not the only one. Okay. So reproducibility is a problem. So the bottom line is that in the past years, AI became like really, really easier compared to what it was. You don't have to do like your entire MLOps cycle like end to end, train a model and everything. Like I can tap into incredible inferential capabilities with an API, but data, not really. The data platform remains kind of like weird and like taped together. So essentially what we did is sit down and think about what is the simplest data platforms that we could think of, literally. It's like, what is the simplest version of this that is simple enough for people to get started quickly, to have different types of developers sharing the same abstractions, and at the same time, to be robust. Because ultimately, we want to build applications, and applications need to be robust because they are out there in production serving customers, right? So let's start with that. Let's start with storage. What is the simplest infrastructure for storage out there? Well, that's easy. It's usually object storage. Like everybody has it, everybody understands it, it's easy to reason about, is infinitely scalable, honestly, kind of cheap, okay? And it seems also that like the industry is definitely going towards using object storage as the foundation for data platforms coming in the next years, right? So object storage shall be. Now let's go on the other extreme, like the runtime. So what is the simplest possible runtime? A lot of the problems that I just talked about kind of boil down to the runtime, because you have like either SQL engines or warehouses, so your runtime is kind of like scattered around and you have data silos, or you have to use like big data frameworks that I think like they kind of like force you to know a lot about how your runtime works to write the code in the right way. Like you have to know a lot about like lazy execution and distributed systems and the JVM. Like there's a lot of that they ask to you. So the simplest runtime in our mind is kind of like the simplest service that we use in AWS, Lambdas, just functions. So I have a function and somebody else is going to run for me in the cloud. And it's like easy enough for people to understand how it works. It's a very simple programming model. So we're going to go for function as a service as our runtime. So now I have object storage and function as a service, but that's not a data platform. Now that's just a bunch of files on S3 and functions as a service. So how do we think about the data piece, which is like one of the most important components? First of all, how do we want to represent the data? Files are not a great abstractions, so we're going to go for tables, because tables, everybody understands them. They're just columns and rows, right? But also, we also want to make sure that we have a way to version our tables so that, in the context of being more software engineering oriented, we can work with our data in the same way in which we work with our code. We can travel back and forth in time to different versions so that we can have some kind of like Git for data. So that will help our robustness and our ability to reproduce the problems that we have, that we establish tends to be pretty problematic when we run pipelines in production. So how do you achieve that? Well, luckily enough, the data lake community comes to the rescue. And in the past years, enormous progress has been made in bringing table-like capabilities into the data lake with open formats like Iceberg or Delta Lake or Delta Tables or Hudi. What essentially these things do is they decouple the actual realization of the data in the files that actually are your data files in your S3 bucket with the logical representation of a table, right? And you get like all the nice things you get from tables, ACID transactions, schema evolution, and most importantly, you get data versioning. So you can actually do now data versioning in a way that doesn't have to be at the file level. So we don't have to save different versions of the same table, copying the data over and over. What we can have is basically zero copy versions of the same table. So we can go like now have an abstractions that we can use to do Git for data, essentially. We can build an abstraction for Git for data on top of versioning. So this is what the entire system looks like. So I'm going to spend a little bit of time here and we make sure that we understand exactly how it works. Let's start from the bottom. So your data is in an S3 bucket and it's going to stay in an S3 bucket and it's just a bunch of files. We're going to take those files and we're going to import them into Iceberg tables. Those Iceberg tables, that means that your data is still in S3, but we're just going to interact with it as tables, okay? Now, once they are in the table, they are in a specific branch of the data catalog. So we're talking about a specific version of the tables that we're going to work on. Now we can run compute on top of that. And compute comes in two ways, right, in two fashions. Asynchronous pipelines and synchronous interactive queries, okay? So let's start with asynchronous. The developer will write functions. So it can be also SQL, but let's focus on Python. The developer basically writes a Python function. The Python function takes a table as an input. So when that function is submitted through a run API to the system will do this. It's going to spin up a container for this specific function. It's going to mount the dependencies that are needed to run this specific function. Let's say that we need pandas because we're going to do like data wrangling. And that function now is going to read the data, it's going to do an S3 scan, and it's going to bring this data as an arrow stream inside of the memory of the process that is running the function. Okay? Now the function runs, as in it runs whatever transformation the developers wrote in the function, and it's going to spit out an arrow table. The arrow table can optionally go back as an Iceberg table into your S3, so you can write a new table into S3 back, or it's going to go into the next function. The code, the environment configuration, and the data of this function are going to be saved in a database. And then we kill the function. So the function now disappears and frees resources that are used for the next function. The next function takes as an input the output of the first one as an arrow table. For the second function, I'm going to do training, so I'm going to need torch. So this is going to be a different container that mounts torch, and it's going to do the same thing. It's going to run the computation that the developer wrote in the function. It's going to spit out an arrow table that can optionally become an Iceberg table back in S3, and it's going to go in the next function. And then again, data, configuration, environment configuration, and code are saved in a database, and then we kill this function as well. And we repeat. And that's all there is to it. It's just a bunch of like ephemeral functions on top of S3, vertically integrated with a Iceberg catalog in this case. Now, I also want to issue a query and actually do an interactive query. So I want to see like what table I just wrote into S3. What do I do? Well, you're going to use another API that is called query. And you're going to just like write a SQL query and submit the SQL query to this API, and the system is going to create another function. Again, ephemeral. This time there's going to be like a DuckDB query engine inside of it. And this time what it's going to do is like an S3 scan, gets the data, and again the data becomes like an arrow stream, but this time it's going to be made available over the wire as an arrow, as a flight server endpoint. And then again, it's going to die. That's all. That's the entire data platform. It's just like functions over branches over Iceberg tables. Why is cool? Because when you use it, this is ridiculously simple. So this is what a data scientist will do. You import your data platform like you do with, like any other Python package. And you start like creating like a branch of your data. So you do a simple API call like branch create. So now you're in a sandbox version of your data in your data lake. This is data coming from your production environment, but it's not really the production table. So, you can screw up. And you're gonna start building your pipeline. So we're in the column 2 of the previous, of the table, right? So we're iterating, we're building. How do you build it? Well, it's just a bunch of Python functions. They're very simple. If I need pandas, I tell it in the decorator. If I need torch, I tell it in the decorator. What is the input? Well, the input is a table that is called NYC taxi. The columns are column 1 and column 2. The filters are that. Do I need to know that this is an Iceberg table? No, I don't. Do I need to know that this is a Hive table? Do I need to know like where this data is? No, I don't. As far as the code is concerned, it's purely declarative, is just a table in a Python function as an input. So this is like what your pipeline is going to look like. And when you run it as I just described. You submit to the run API, and you're going to run it like as ephemeral functions. Now we go to the column 3, when we have to put this into a production environment. So all the scheduling and all the like the resource optimization and so on. What do we do in that case? Well, first of all, the code of the pipeline will not change. It's the very same function that we built in column 2 when we were building. We're going to do, as a DevOps and data platform team, a little bit more checks when it comes to CI/CD and things like that. And we're going to use essentially the very same functionality as we used before, But this time, we're going to use it as a Python SDK, so we can program this. This is just a script, but you can see like this can be just like something that you use in Prefect or Airflow. You just like embed this calls of a Python SDK inside of orchestration tasks. And you can program this endlessly. It's just code. And when something breaks, now we have a platform that has, remember what I said, code, environment configuration, and the data are saved every time we run. So we have the three things that we need for the reproducibility checklist in one place. So let's say that something breaks and I want to rerun it. Well, every run has a run ID. If I pass to the system that run ID, the system can just like go fetch the data, the configuration, the environment configuration, and the code that produced that specific run and just rerun it deterministically in just like one line of code. You can do the same like to get like the logs of that specific run. You can ask to print the logs that we saved in the database. You can find a commit that is corresponding to that run. So you want to see what that run did to your data lake. Did it create new tables, delete a table, delete rows, added columns? What did it do? Well, if you have the run ID, I can give you a commit list of what happened during that run. So now I basically have the possibility of reproducing this really like I would do with a software application, because everything here is basically reduced to typed, structured APIs that are very easy to learn, and they're just Python objects. So I can now endlessly program this. Now it's just software, it's just code. So when you go back to the infamous table of complexity before, we actually achieve a lot of simplification here. Because the runtime, that used to be like 3 different separated things, is now just like a bunch of ephemeral functions, right? Your interface is going to be VS Code, right? Which is the interface that, again, like all the people, all the groups of people that I showed you before, like share. Data scientists, DevOps people, and software engineers. And your abstractions are really kind of things that you should know straight out of CS grad school, right? It's just functions, dependencies, Git, and tables. And the tables are pure declarative, so all you need to know is that there are rows, columns, and filters. So it's very, very simple to learn. And the bottom line of what we kind of like wanted to achieve here is that, so there was a moment a few months ago when we saw like one single enterprise starting to use the product, starting to use the platform. You just have this spike in usage in a few weeks that caught us honestly by surprise. And the reason why they went from, you know, like this kind of like POC thing, and then like all of a sudden it was like, oh, there's thousands of runs from just like one single client. What is happening? Is because now we have like 3 different personas that can actually work on the same platform. We have the data scientists, we have the data engineers, but we also have the DevOps people that automate a lot of work by using like Lambdas or using their CI/CD pipelines. So that now is called by a machine and not by a human. We get like a spike in jobs. So as of today, we serve basically fairly, widespread use cases. A lot of data transformation, like a lot of stuff that is, I think, boring, but kind of like necessary, right? We do a lot of analytics and machine learning pipelines that are like more ad hoc or just like small machine learning models. And of course, like now we start to do like more Gen AI because the platform is essentially built for you to build like an entire application in pure Python. And that's how, people build like RAG systems or just like, it's mostly like RAG systems right now, applications in production. So this is what you see like in the real world. And I know that like also this conference, like a lot of, we talked a lot about agents. And I have the feeling that agents right now are a little bit of a time-space warp in my LinkedIn feed that is created by us mostly, yeah. But I'm gonna show you something that one of our users built on the platform using an MCP server, which is basically embedding this entire platform that at this point is just a Python package, and have it talk to an agent that can learn how to use the data platform. This data platform collects like a lot of data from sensors, and is designed for, the agent now can go out and if you ask the agent, hey, give me like all the logs, now the agent is actually able to know the shape of the data just by one API call. It can know like where the data, like all the comments in the history of what happened on the data just with an API call. So it's essentially an entire data platform in just a handful of APIs. And this is like particularly exciting for us because of course like developers are really good at code, but it seems that agents are also very good at code and they seem to become better and better. And so we see the future going more and more in this direction. That's what we built, essentially, and I hope you think that this is simple enough for you as it was simple for us. If you can come up with something simpler, we would love to hear from you. This doesn't work, of course, like for all use cases. There's no such a thing, but like for the bulk of your use cases, this is surprisingly robust and really, really, really easy to use. We're also hiring, so get in touch. Thank you.